So last week we learned about how to prove triangles guilty of being congruent. And we decided we don't have to check all 12 things. We don't have to check all 6 sides, all 6 angles. We have shortcuts. So we learned certain shortcuts, and they are side, 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 angle, side, angle, angle, side, and the last one was HL. Very good, okay? We also learned that there are certain times that you're allowed to add something to your picture. In number 1, I'm allowed to add tick marks because those two triangles are sharing a side. It's also called the reflexive property, which we'll learn more about today. They are sharing that side, so I'm allowed to add tick marks to that side. And then I look at what I have. You have to evaluate. Oops, I undid that. You have to evaluate what you have. I moved them. So in this picture, unfortunately, those triangles do not match. Do you see how they don't match? The first one, there's a side, and there's an angle, but the angle is not between the sides. Do you see that on the first one? This angle is not between the sides where it should be. On the second one, here's number 1 and number 2. On the second one, the angle is between the sides. So number 1 is not possible, because we're trying to determine if the triangles match, and those triangles don't even match. The angle was not between the tick marks on number 1, and it was between the tick marks on number 2, and so it's not possible. And on today's quiz, you would write not possible in both blanks, NP, NP. Number 2, that one also has a shared side. It's a kind of a different shared side than we're used to, but go ahead and add tick marks to it. Oh, why or why not? Okay. So on number 1, we're going to put NP and NP. We're going to put it twice. On number 2, can they be proven congruent? That should be a question mark. We're going to write yes. And then for the Y, on this one, we're going to write angle, angle, side. That's how your quiz is going to ask it to you today, so that's why we did that in the warm-up. Thank you for actually reading the directions. Good job. I hope you practiced on your homework. This was a really good practice for the quiz. No, Ganesh, it's not a new unit. We started this unit last week. Today is not a new unit. The new unit started in the middle of last week. It's called Congruent Triangles. Look at those answers. Make sure there's no mistakes, because there has been lately, huh? Okay, let's start with number 5, and then we'll go to 13. Take a look at number 5 with me. Okay, number 5, what can we add to our picture? Can you see that? I'll zoom in while you're looking at number 5. What can we add to our picture? Because that's what you always look at first. What am I geometrically allowed to add? What am I geometrically allowed to add? Nothing. You can't add anything to number 5. So number 5, all we have is angle, angle. Sure. No, you're right if you say that we could conclude that this angle is congruent to this angle. And it's not because of vertical angles. That's not why. It's because if 2 angles of a triangle are congruent to 2 angles of another triangle, then the third angle is congruent. I agree with that. I agree that angle IRD is congruent to angle ERG, but angle, angle, angle does not prove 2 triangles guilty of being congruent. Angle, angle, angle is not one of them. Can you add a triangle? Adding a triangle would not help us. On number 13, this one was different. Give the angle or side that allows you to show that the triangles are congruent by the given theorem. So on number 13, we had to use side, angle, side. And for BCD, this triangle, they gave us BC, put a tick mark. They gave us BD, put a tick mark. And now it has to be side, angle, side. So there's only one angle that we could say needs to have a marking on it. It's this angle right here. It has to be the included angle. Okay? So then you asked about the last two, which are the algebra ones, right? Okay. Angle K is listed first. Angle N is listed first. Angle L is listed second. And angle O is listed, oh, nope, it's not listed third, it's also listed second. So that's what I would do first. I would take inventory of, hey, what did they even give us? Now, the good news is we are not going to have to mix x's with y's. They're not going to have to mingle because our x's are going to stay separate and our y's are going to stay separate. 4x squared plus 6 equals 2x squared plus 24. 2x squared equals 18. Do we keep the plus or minus? It looks like it. No matter where we plug it in, we're not going to run into any trouble. So now we have to find y. Oh, you know what you did wrong now? You know what you did wrong? Okay. So then we plug them both back in. Someone else might be wondering. So 4 times 3 squared plus 6. So angle K is 42. Then let's go to angle L. 5 times 17 minus 42. This one's 43. K and L are two angles in a triangle. Now we can find the third angle by adding them up and subtracting from 180. Yeah, that'll do it if you didn't do that. And angle O is, not angle O, sorry, the remaining angle, so angle M and angle P are both 95. How did we get that? We added these two up and we subtracted from 180 because it was a triangle. Very good. Last one. Let's see, we're given angle D, listed second, angle G, listed second, and then we're given side GH. This is a factoring problem, so we're going to move everything to one side of the equation. 39 plus 17, go. 56. So now we need things that multiply to get 56 and then subtract to get a -1. So 8 and 7. X, 8, 7. We want our middle term. Our middle term is -1, so it needs to be negative. We want to create a -1. Good. So -8 plus 7. And then when you solve, x is 8 and -7. I don't think that either of those are going to cause a problem for us, right? That's why 18 has two answers. Because when you plug in 8, everything looks fine and dandy. And when you plug in -7, everything is fine and dandy. So that's why there's two answers to number 18, 15 or 60. Okay, today our lesson is called Justifying Statements. Justifying statements. So it's like you're arguing with your parents and you're backing up your argument, right? You can't just say, well, because, right? You have to have reasons to back up your argument. So that's what we're going to do today. We're going to justify what we're saying. So our job, we're going to give you a true statement. I'm going to give you a true statement. And your job is to explain why it's true. You have a whole sheet of reasons why properties can be true. There are 45 on there, at least. Most of these you already know. So I don't want you to be intimidated by this list. You know most of these. Most of these are common sense to you now that you've practiced them. And so I don't want you to think of, oh, I have to go home and spend hours and hours memorizing this. No, you don't have to memorize the number. You don't have to memorize the order. You just have to know when to use them. And let's figure out what that means, okay? So the first 2 through Yep. 2 through 10, we're not really going to use because those are to prove algebraic things, and we don't have enough time to prove algebra. So we're just going to prove geometry. How about that? So don't worry about 2 through 10. You won't ever, can I say that? You won't ever use 2 through 10, I believe. So don't worry about those. The rest of them you need to worry about. There's one other one that we're not going to use. Go to number 26 if you already have it. Yeah, it's on the calendar for today, Edriel. If you don't already have number 26, or if you don't already have this paper, then you'll print it out later. But number 26, you're also never going to use that one. We never use the definition of vertical angles. We just use number 27. Number 26 and 27 go together, and we just decided to not use 26 and to just go straight ahead and say that vertical angles are congruent. Instead of first saying that two angles are vertical and then saying they're congruent, we decided to jump right in and say they're congruent. So we're going to dive right into examples because I want you to have time for your quiz. So here's how it works. I'm going to give you a conditional, an if-then statement. A true statement is going to be true. And all you have to do is tell me why I'm allowed to assume that that's true. That's all you have to do today is say why. And then the next day, we'll take off the conclusion. We'll give you the hypothesis, and you have to give the conclusion and the why. And then the next day, we'll just take away all of it, and you'll have to give the hypothesis, the conclusion, and the why. So we're taking baby steps. Okay. If BD is perpendicular to AC, then angle BDA and angle BDC are right angles. All I want you to do is tell me why I'm allowed to say that. Linear pair is not the answer. Nope. Look at your list of options. What definition are we calling upon if we say when two lines are perpendicular, we get right angles out of the deal? What number is it? Very good. Everyone go look at number 33 if you have the paper. Number 33 says definition of perpendicular lines. If two lines are perpendicular, then they form a right angle. If perpendicular, then right angle. So you can put definition of perpendicular lines, and that would be your answer. Definition of perpendicular lines. We have not learned CPCTC, so don't say it yet. That's tomorrow, or that's Wednesday actually. If BD bisects angle ABC, then angle ABD is congruent to angle CBD. We know it's true. You're not going to put true or false. You just need to say why. Very good, guys. It is number 16. It's the definition of angle bisector. If a segment bisects an angle, then you get two congruent angles. So the answer to this problem is definition of angle bisector. A lowercase b with a circle around it is the symbol for bisector. You're allowed to use it. It's not a made-up one, it's a real one, okay? Next one. BD is congruent to BD. Oh wait, so we just did this. Good. It is number 1 on your sheet. Number 1, number 1, number 1. When you say something's congruent to itself, it's like you're looking in a mirror, like a reflection. Reflexive, reflection. When you look in a mirror, you see yourself. When BD looks in the mirror, he sees BD, right? So BD is congruent to BD. The answer is reflexive prop. Reflexive. What if you don't see yourself? Then you don't have a very good mirror. Okay? So what just happened? Look at our picture. We just proved that those angles are right angles. We just proved that BD is congruent to itself. We just proved that those two angles are congruent. So what do we have? Oh, we're not doing a proof apparently. We're just justifying statements. Never mind. I thought we were going to prove these congruent by angle, side angle, but no, we're just going to keep going. If D is the midpoint of AC, then AD is congruent to DC. What allows us to do that? What definition? Y'all were already there? Number 12, very good. See how you see the word midpoint and the answer is definition of midpoint? See how you see the word perpendicular And the answer is definition of perpendicular lines. See how you see the word bisect? And the answer is definition of angle bisector. So a lot of times on this stuff, the answer is in the question. The answer is in the question. So this one is definition of midpoint. There we go. Ever since I updated Smart Notebook, it's been lagging. Because, why ask the question? Because we're doing baby steps to proofs. So you'll be glad that we're doing this one step at a time. You'll be glad. If AE bisects BD, then BC is congruent to CD. What allows us to say it? Good. Number 13. Definition of segment bisector. So you do need to be careful. You have to say whether it's an angle bisector or a segment bisector. So you can't just say definition of bisector because that's not specific enough. So make sure you're saying whether it's an angle bisector or a segment bisector, okay? BCA is congruent to ECD. What allows us to say that BCA is congruent to ECD? What allows us to say that? Good. Number 27. Number 27. Vertical angles are congruent. These two you had to know, you had to use your knowledge that those two angles were vertical angles. What allows me to say that they're congruent? Well, because all vertical angles are congruent, and someone proved that a very long time ago, and now we get to use that in our proofs. We get to use what they proved in our proofs, because you don't need to reinvent the wheel every time. 27, yep, vertical angles are congruent. Here's what you don't write. You don't write definition of vertical angles. We even cross that one out. I don't even want you to write it, okay? We got proof, that's right. If B and D, if angle B and angle D are right angles, then angle B is congruent to angle D. Very nice job. Everyone go to number 17. What does number 17 say? All right, angles are congruent. It doesn't say definition of right angle, does it? Because that sentence is not saying that B and D are right angles. That's not what it's saying. It's saying that because they're right angles, they're congruent. And that's different, and that's the hard part of this lesson, is finding out what that sentence is really trying to say. It's trying to say that because they're right, they're congruent. So the answer is, number 17, all right angles are congruent. All right angles are congruent. If AB is parallel to ED, then angle A is congruent to angle E. Good job. On top of it. The good thing about this is they gave us shorthand notation. Everyone go look at number 28. Ooh, no, it's not 28. It's 29. It's 29. Go look at 29. It says, if two lines are parallel, then alternate interior angles are congruent. If two lines are parallel, then alternate interior angles are congruent. Look below that, though. Look below those bold letters. There's a shortcut there, and you're allowed to write that shortcut. So you're allowed to write, if parallel, then AIA congruent. But you have to write it just like that. Can you just put AIA? No, you can't. You have to state the hypothesis and the conclusion. If two lines are parallel, then alternate interior angles are congruent. Okay? If parallel, then alternate interior angles are congruent.